All right, here we go. So this is just inverses continued. All right, the main thing with the inverse is we have different kinds of notation. So if you missed yesterday, you want to jot this down. We have function notation like this, f of x. That's just our regular function. That's our regular function. So it could be, x plus 2. Right? The inverse is different. This is just an example. An example of the inverse is this notation. Okay. And this might be x minus 2. Okay. So inverse notation has the -1 there. But just remember that this doesn't mean f to the -1 exponent times x. F of x is just given as function notation. So in this case, remember function notation, if it was f of 2, I would go in and I'd put the 2 everywhere there's an x. I'd put the 2 everywhere there's an x, and then I would have f of 2 is equal to 4. So because it's set up that way, we just have to remember when we're finding the inverse like we are today, we got to label it that way. We got to label it just like that. Okay. So let's see, what else? We had 4 steps. 4 steps. And we're going to do each step one at a time for this pretty easy just linear equation right here. So let's go ahead. And the first thing is to change your f of x to be just a y variable. So I'll go ahead and do that step right here. Oh, this was f of x, but I wrote it wrong. So we have to change it to be y. And that's also something that you could put a little arrow right here. F of x notation, function notation, when you have f of x, it's equal to y. That's synonymous. It's the same thing. F of x is always the y variable, and we just can replace it like we did right here. Okay. Let's see. What was next?
We'll do the inverse of 7.
Almost. You're solving already. We got to do one thing first, then.
You gotta switch the y.
Got to switch it. You got to switch the y and the x. Switch. You actually got to switch. That's not what you said, right? No. Not quite. No, not quite. All right. So we're switching the x and the y. So go ahead and actually pick them up and place them in the other position here. So we switch them. Okay. So we did the switch. Okay. What came next? Someone that was here yesterday. What do we have to do after we switched them?
You had 7.
So you're saying add the 7 in order to do what? There we go. We're going to solve for y. So go ahead and solve for y with this right here. Solve for y. And I'm going to call on somebody, cold call. So let's see if we can do solving for y on the bottom line there. So we get y isolated all the way down. Where's the Sharpie? Is it making it right?
Oh, yeah, I did. I just put it.
Oh, okay. Anyone else need a Sharpie? All right, this group over here missed it.
Oh, I don't know.
Please put your name on the workbook. They get lost, it's hard. All right, check with your neighbor. Check with your neighbor. I'm going to cold call somebody, so make sure that you have a good idea. Check with your neighbor if you got the Y.
That number 3, is that that's not a part of it.
This. What about it?
Is that number 3?
This is the third step. First step, change it to f of x to y. Switch it. So they're not different problems. That's the step. That's the step. So we switch the x to y, and now we're solving for y. All right, let's see. All right, I'm going to ask Estrella, help me out. What are we going to do to solve for y in this case? We need to get everything isolated. We've got to get y out of there. think of it like peeling an onion outside in. So I want to get to the y. What's on the outside that we can chop off first? You know?
Oh wait, you would add.
Yeah. Don't touch stuff. We're doing this for almost 2 years. +7 + 7. Write down the back, please. Thank you. -5y. And I'm going to let you finish this up because you got this. No problem. -5 times y. I don't want that -5 there.
Can you divide it?
Yeah. Divide by what?
5.
Just 5? That wouldn't give her.
No, -5.
Good job, sir.
So yeah.
Shut up.
Shut what?
Oh, yeah, that was fair. In trouble.
Trouble. The one way to get in trouble. Great. We solve for y right here. But here's the deal. All right, Sam. Just quiet down. If you're whispering, whisper. So we have a y right here, right? We also have a y over here. So we don't want to get confused. So what was the last step? We just have to make sure we're remember what the heck we're doing. Let's change the y to the f -1 of x. So switch it back. Perfect. Just rewording what you said. Perfect. So, I mean, I'm not going to write it again. I'm just going to actually come in and that's our answer. We're not concerned with the domain and range for this lesson. So pretty much this is just a lot of practice, finishing the equations, solving the equations. I think a lot of you are a little bit rusty with that. So that's what this is. This lesson's good for as well. So let's see. Let's do another. How about this one? Okay. Yeah. That. Okay. Just from the beginning? Actually, I'll start from the beginning where you guys will. Alright, so go ahead and do as many of the steps as you can. Step number 1 is pretty straightforward. We just got to change that f of x to be just an x and y. So we're going to change it to be y. Alright. Zoom in. Let's see if this works. Okay. All right. Step 1's done. Step 2, Nadia, what are we going to do? Just switch them, right? So the reason why we're switching it, if you're curious, like why do we do this, right? The inverse, if you go on to pre-calc next year, the inverse is all about this line, x is equal to y, right? So x equal to y at 0, 0, 0 is equal to 0. At 1, 1, right? X equal to y. At 2, 2, x equal to y. At 3, 3, x equal to y. And what we're doing when we're doing the inverse, if you had an inverse or you had a function that looked like, say, this, the inverse takes it and it takes all the x values and changes it to be the y values. So it just reflects it across that line. So the inverse of that would look like that. Okay. So you can see that instead of it being at 0, 2, it's at 2, 0. It switches the x and the y. So when we're finding the inverse, we're finding that other equation that is exactly like it. It's just on the other side of that x is equal to y. So we switch x and y. It's kind of a weird, just like conceptual thing, but if any of you are curious, that's where we're going with it. So here we're going to switch them. And then get to solve it. Get to solve and switch it back to a function notation, and we'll call it. How do we get rid of a squared value?
We square both sides.
Oh, the opposite square. Square root. Perfect. You know what you meant?
+6 +6.
No, it's not.
One is the y, right? And filling it in. I think on the very outside is that it's always square. So think of it as that expression, y minus 6, that expression is being squared. First you gotta break that square out, square root. So when we get to that, there's a couple problems like this. So this is a good example that you have for the homework. All right, check with your neighbor real quick. We're gonna come back in 10 seconds. 10 seconds, we'll come back.
Yeah, that means it.
This could be a thinking today.
Yes,
You got 100% chance.
it's supposed
I
to
don't know, one problem. I like it.
I didn't make yours.
I want to record a video and have it right in there. Okay. All right. Let's see. All right. Let's see. So, Natalie, give me the first step.
Square root all that.
This and this expression is being squared. If I want to get into that expression to get to the y, I need to first, like an onion, peel from the outside in. I need to go for that square. So I'm going to go square root. Square root. What's going to happen with the square and the square root? They cancel each other. It's the inverse. So the inverse always cancels. Root x is equal to y minus 6. And Noah, finish this up. Plus 6? Add 6, add 6. You can't have an x plus 6 being rooted. It's going to be separate because these are separated by this root. So it's going to be outside of that root. Make sure you have that aspect. Okay? Because essentially this x is x to the 1/2. You can't subtract 6 from that, or add 6. It has to be on the outside. All right. Very last step. Very last step. Adriana, help me out. Last step.
You just have to do y for f minus 1.
Good. The inverse function of x. Good. So yeah, the last bit is going to be the square root of x plus 6. We just change it back to the function notation. We've got to say, oh yeah, it is the inverse of that notation. Right? You see it? So I think tomorrow, I'm not going to have you graph them because half the people aren't here. You guys have testing every day all week, right?
Yeah. Wait.
Yeah. Not Fridays, not Fridays.
Okay. Every other day.
Yeah, so it's Monday through Thursday.
Yeah.
Okay. So next time we have an actual regular Friday, maybe
Yeah.
we'll all be together. We can try to graph. All right, thumbs up, sideways down for this. Thumbs up, sideways down. You've seen this before. You're good. I'll show you one more. One more. And yeah, no problem. All right, let's try this one.
So we can
Okay. Next problem's up. I'm going to come around on this one. I'm going to let you do all 4 steps. Call me over if you're not sure. And wait till you try it before you check with your neighbor. So we have this up here. This one's a little bit trickier. But I have confidence in it. I have confidence. Okay.
Wait, is it?
The plus 5 is inside the root. So first we gotta break the root out.
Why is it greater than equal?
Just need that at the end. Let's see. Let's forget about this for a moment. Let's forget about that part. Okay. Don't worry about it. Don't worry about it. But let's all work on the problem. I know there's a lot to talk about. Let's do the problem. Y is equal to the square root of x plus. Oh, you guys are. I confused you. I'm sorry. That actually was on purpose.
That makes more sense.
Yeah, I was like, oh.
Oh, you got me, Sam. Do you want it? You don't want any candy.
Oh yeah, that was good. Oh, yeah, I'll have some.
Get it, I want it.
No, I really want it. Thank you. Wait, like that?
All right, don't just wait. Don't just wait till we get to it. If you try it and if you don't make it through it, you know where you're messing up. So find your crux. If you don't know how to do it, find where you get lost. We'll figure it out.
So that's kind of far.
No, you can come sit over here if you want to work together. All right, a lot of people are checking the neighbor. Keep checking. Last 10 seconds. All right, let's see. Help me out. All right, who's going to help me? All right, I'm going to call on people for each step. All right, let's see. Rocky, what's first? How are we going to?
I changed after next.
Perfect, perfect. So I'm just going to write a little. Oh, nice thing. Thank you. Let's see. Jackie, what's next?
Switch the X on the wall.
Switch them. All right, that's perfect. That's perfect. That's perfect. Kaylin, how are we going to solve for y? What should we do next? Square the square root, both sides. All right. The opposite is squaring something, square rooting. The opposite is square rooting, squaring. So we go in and square both sides. What's going to happen on the left? See ya. So 1 sec here. Squares.
Yeah, I do have him here today.
Oh, ASAP. I guess you got to run. Wait. Does yours say ASAP as well?
Yeah.
Yeah, why don't you guys go real quick? Let's see. Yeah, here. What are we going to do to solve for y from here? Good job. -5, -5. Goodbye. Now y is equal to, not to you guys, just to the positive 5. Good bet. Last step. Sam, what's our last step?
Oh, I've made the y f of x
Just this
with the minus one.
with the minus. Alright. So just make sure that you don't forget it's the inverse. Otherwise, you might get confused with
Me
that.
too. I did it on my own too. Oh, sorry.
Boom. No, that's good. All right. So now I want to look at this for a sec. Why did we have y is greater than or equal to 0? Why do we think y is greater than or equal to 0? Not sure. Okay. Let's see. So I think this had to involve when we were graphing it. We're not going to graph it yet. Actually, now that I look at it, that's what we're looking. That's what we have here. The other thing could be square root 5 negative 0 square root 0. That would work too. No, it's having to do with graphing. So it was not part of it. We are done. That was the inverse. So let's go ahead and get going on the classwork. You guys have a good amount of time still. I gave you 25 minutes. All right, if you're watching video, keep watching and subscribe.